The secret history of everything, from the void before time to the last light of eternity. There are truths so vast, so terrible, so beautiful, that civilizations built temples simply to survive knowing them. Prologue. Before creation, the void that waited. Before the first star burned, before time learned how to move, before existence itself had yet decided what shape it wished to take, there was something else. Not darkness. Darkness is merely the absence of light, and light had not yet been born. Not silence. Silence is merely the absence of sound, and sound requires a world to carry it. What preceded everything was not nothing. It was something far more disturbing than nothing. It was a state for which no human language has ever found adequate words, a condition beyond potential, beyond possibility, beyond the very concept of before. Call it the void, call it the abyss, call it the unmade. Every civilization that ever gazed up at the stars and trembled eventually felt its presence at the edge of their mythology, the great darkness that preceded all things. The Sumerians called it the primordial waters of Namu, the deep from which all creation swelled. The Egyptians spoke of Noon, the boundless dark ocean that existed even before the gods. The Norse traditions remembered Ginnungagap, the yawning void of primal emptiness. The ancient Hindu texts described the cosmic night of Brahma, a darkness so total that even the gods had not yet dreamed of themselves. And in the Hebrew tradition, 4 words that have haunted philosophy for 3,000 years: tohu wabohu, the formless and the void. These myths are not poetry, they are memories, crude, ancient, imperfect, but memories nonetheless, because something happened in that void, something that science now confirms with equations written in the language of mathematics, a language no less mythological than the ancient scripts that came before it. Something happened, and that something is the reason you exist, the reason there is something rather than nothing, the reason the stars burn, the reason the earth turns, the reason a single species on a single small world ever looked upward and dared to ask, why? The universe did not begin. It erupted, and the scream of its birth is still echoing through everything you have ever seen, touched, loved, or feared. Before we begin the story of everything, a warning. This is not a comfortable story. It is not the story civilization tells itself at night to feel safe. It is the story that was always true, always enormous, always humbling. The story that swallows human significance the way an ocean swallows a grain of sand. The ancients knew that to contemplate the full weight of existence was to risk being broken by it. The great mythologists, priests, and philosophers who dared to look directly at the cosmic truth almost universally described the experience as both devastating and divine. What follows is that truth, the complete truth, as best as our most powerful instruments and deepest equations can recover it. The story of how existence came to exist. The story of fire and silence and stone and water and life and memory and loss. The story that begins before beginning and ends after ending. The story that is, in the most literal and terrifying sense, the story of everything that has ever been. In the beginning was the void, and the void was without form, and the void was patient, and the void had been waiting since before waiting was possible. Pay attention. This is your story, too. The universe awakens. The singularity. 13.8 billion years ago. T equals 0. The Planck epoch. An impossible compression. Everything, all matter, all energy, all space, all time, crushed into a point smaller than thought. The universe was born screaming, not from somewhere, not into something. The universe did not explode outward into pre-existing space the way a bomb shatters into a room. There was no room. There was no outward. Space itself was born in that moment. Time itself was born in that moment. The very fabric of reality erupted from a state of infinite density and infinite temperature, so extreme that all four fundamental forces of nature were fused into a single unified force, a force that no human laboratory has ever recreated, a force that our best physics can describe mathematically but cannot fully explain, a force that preceded the laws of physics themselves. We call this moment the Big Bang, but the name is wrong. Wrong in a way that reveals how utterly inadequate our language is for describing it. It was not big, it was infinitely small, a singularity, a point of zero volume and infinite density. And it was not a bang. Sound requires matter, sound requires space, sound requires time. At the moment of creation, none of those things yet existed. What happened was not an explosion. What happened was the invention of explosion, the invention of matter, the invention of space, the invention of time, the invention of the very concept of happening. In the first second of existence, more violent transformation occurred than in all the billions of years that followed. Creation is not gentle. Creation has never been gentle. Consider for a moment how ancient peoples tried to describe this. The Rig Veda, one of the oldest surviving texts of human civilization, contains a hymn called the Nasadiya Sukta, the hymn of creation, that dates to at least 1500 BCE. It begins with words that should stop your breath. There was neither non-existence nor existence then. There was neither the realm of space nor the sky which is beyond. What stirred? Where? In whose protection was there water bottomlessly deep? Even the Vedic sages, 3,500 years ago, intuited what our instruments have now confirmed, that before the Big Bang, the question, what was there, may not have a meaningful answer. Because time itself began at the Big Bang, and before requires time. The singularity existed, if existed means anything, in a state outside the reach of physics, outside the reach of causality, outside the question why. The Planck epoch, the first 10 to the negative 43rd seconds, is a region of reality so extreme, so compressed, so alien to human intuition that our laws of nature simply fail. Gravity behaves like the other forces. Space and time froth and bubble in a quantum foam more violent than any storm that has ever swept a planet. The temperature at this moment was 10 to the 32 degrees Celsius, a number so large it has no analogy in the physical world, no material, no star, nothing that has ever existed in the observable universe has reached this temperature since. Nothing ever will. And then, in the fraction of a fraction of the first second, an event so extraordinary that the physicists who first theorized it were themselves stunned by its implications, the universe inflated. Not simply expanded, inflated. In an interval of time so short that describing it in words requires an absurd number of decimal places, the observable universe expanded from a region smaller than a proton to a sphere roughly the size of a grapefruit. The expansion was faster than light. Not violating the speed of light, space itself expanded, carrying the fabric of reality with it, and space can expand at any speed it chooses because it is not moving through anything. It is the thing that things move through. This period of cosmic inflation, theorized by physicist Alan Guth in 1980 and supported by extraordinary evidence since, solved three deep puzzles that had plagued cosmology. It explained why the universe looks the same in all directions. It explained why the geometry of the universe is so perfectly flat. And it explained the origin of all the structure we see, every galaxy, every star, every planet, every human being, as the quantum fluctuations of that primordial impossible density stretched by inflation to cosmic scale. The large-scale structure of the observable universe, the galaxies, the galactic filaments, the great walls and voids of the cosmic web, traces directly back to quantum noise in the first fraction of the first second of existence. You are the descendant of a quantum fluctuation. Think about that. The arrangement of atoms that constitutes your mind, your memories, your loves and fears began as a tiny shiver in the fabric of a newborn universe. Ancient mythology called it the Word of God, the breath of the divine, the vibration of the cosmic string. Modern physics calls it quantum uncertainty. They are describing the same moment, the first cause, the tremor that became everything. The gods of antiquity were not wrong to worship the moment of creation. They were simply missing the mathematics. The awe was always correct. 3 minutes after creation, the universe cooled enough for the first atomic nuclei to form. Not atoms, not yet, just nuclei, the basic building blocks. Protons and neutrons, newly cooled from their quark-gluon plasma, began to fuse. In a 3-minute nuclear reaction that will not happen again until the very last stars die, the universe manufactured the hydrogen and helium that make up 98% of all visible matter. The entire periodic table begins here. Every atom of hydrogen in every ocean on every planet that will ever exist was forged in those 3 minutes. 3 minutes. This is a detail that destroys the mind when considered fully. The universe that contains 100 billion galaxies, each containing hundreds of billions of stars, each star shining for billions of years. The basic material for all of that, the hydrogen that fuels every star, the hydrogen that makes every ocean, was manufactured in a period of time shorter than it takes to soft boil an egg. Creation is the most efficient process in the history of existence. It does not waste a moment. For the next 380,000 years, the universe was opaque. A plasma fog so dense that light could not travel more than a short distance before being absorbed and re-emitted. The universe was hot, bright, and completely invisible. No observer, had any existed, could have seen more than a few feet in any direction through that blinding, primordial murk. The universe was a furnace, and it burned alone, and it burned in silence, and nothing could see anything, and nothing existed to want to see. And then the universe cleared. The temperature dropped to roughly 3,000 degrees Celsius. Electrons, for the first time, could combine stably with nuclei to form neutral atoms. And when they did, the fog lifted. Light, for the first time in the history of existence, could travel freely across space. The universe became transparent. Photons that had been trapped for 380,000 years suddenly streamed outward at the speed of light in all directions. This moment has a scientific name, recombination. It has another name, more poetic and more accurate, the last scattering surface. Because those photons, that first free light, still exists, right now, at this moment, as you read these words, your body is being gently irradiated by photons that have been traveling since 380,000 years after the Big Bang. They have traveled 13.8 billion years to reach you. They have been stretched by the expansion of the universe from visible light to microwave radiation. We call it the cosmic microwave background, and it is the oldest light in existence. It is the light of creation itself, grown cold with age. Every culture that ever looked at the sky and felt something, felt the presence of something vast and ancient and impossible to name, was feeling this, the echo of the Big Bang, the afterglow of creation. It is still here. It has always been here. It will be here long after the last star has died. It is the universe's oldest memory, and it has never stopped speaking. The universe was born in fire, and its birth cry became light, and its light grew cold with the journey, and now it whispers in wavelengths too long for human ears. But the instruments listen, and the instruments say, "We were there. We remember." Chapter 2. The first gods were stars. The age of stars, 200 million years to 13 billion years ago. The cosmic dark ages, 380,000 to 200 million years after the first light faded. The universe entered an era that astronomers with haunting accuracy called the cosmic dark ages. For nearly 200 million years, a span of time so vast it makes human history feel like a single heartbeat, the universe was dark. Truly, completely, utterly dark. There was hydrogen, there was helium, there was the cold afterglow of creation slowly dimming, and there was gravity, the oldest, most patient force in nature, the force that refuses to be hurried, the force that acts across infinite distances and waits infinite durations to achieve its purpose. Gravity was working, slowly, patiently, relentlessly. It pulled the hydrogen gas of the early universe into denser and denser concentrations. The quantum fluctuations of the first second, those tiny shivering variations in density, had, after inflation, become very slightly uneven distributions of matter across space. Where matter was slightly more dense, gravity pulled more matter. Where matter was slightly less dense, it drained away. Over millions of years, the slight unevenness grew. Dark matter, the mysterious, invisible, yet gravitationally dominant substance that makes up 27% of the universe's total energy content, clumped first, forming the scaffolding. Ordinary hydrogen gas followed, falling into the dark matter halos like water falling into wells. For 200 million years, the universe was dark and cold and patient. No starlight, no planets, no chemistry beyond the simplest atoms, just vast clouds of hydrogen and helium, slowly, slowly, slowly concentrating under gravity's patient hand. The ancient mythologies had a word for this era too, though they described it in terms of divine rest, divine patience, divine preparation. The Egyptians spoke of the time before Ra arose, when there was only the dark water of Nun. The Babylonian creation epic describes the mingling of primal waters before Marduk separated heaven from earth. They were not wrong. The universe was, in a sense, resting, preparing, coiling before the strike. And then the first star ignited. Somewhere in the dark, we do not know exactly where, we do not know exactly when, but approximately 200 million years after the Big Bang, a cloud of hydrogen gas had been compressed by gravity to a critical density. At the center of that cloud, the pressure became so extreme, the temperature so ferocious, that hydrogen nuclei began to fuse. Protons collided with enough force to overcome their electromagnetic repulsion, and in that collision, energy was released. Enormous energy. The energy that powers every star that has ever shone. The energy that drives every photon of light that has ever crossed the cosmos. The energy that ultimately created every chemical element heavier than helium, including every atom of every living thing. The first star was not like our sun. It was a monster, a colossus, a population 3 star, what astronomers called the first generation, so enormous, so hot, so furiously brilliant, that it would make our own sun look like a dim candle. These first stars were hundreds of times more massive than the sun. They burned at temperatures 100 times hotter than our star's surface. They blazed with a ferocity that modern stars simply cannot match, because modern stars are made of elements that the first stars had to create. The first stars were born from pure hydrogen and helium, uncontaminated by anything heavier. They were, in every sense, the most primitive and the most powerful stars that have ever burned in the universe. The stars were the first gods, and like all gods, they were violent, brilliant, generous, and doomed. The ancient skywatchers were not being poetic when they called the stars divine. They were being accurate in the deepest possible sense, because the stars are not merely burning gas, they are the universe's mechanism for creating complexity. They are cosmic forges, manufacturing every element heavier than hydrogen and helium through nuclear fusion in their cores. Carbon, the backbone of life; oxygen, the breath of life; iron, the blood of life; gold, silver, silicon, calcium. Every element in the periodic table heavier than helium was forged inside a star. Every atom of calcium in your bones was once fused in the nuclear fire of a dying sun. Every atom of iron in your blood was once the product of stellar nucleosynthesis. You are not made of the universe the way a painting hangs on a wall. You are made of the universe the way a wave is made of the ocean. You are the universe looking at itself. The first generation of stars did not live long. They could not. The more massive a star, the more furiously it burns, and the shorter its life. A star like our Sun burns for approximately 10 billion years. The Colossus stars of the first generation burned for only a few million years, a cosmic eye blink, before exhausting their fuel and facing the inevitable reckoning that awaits all stars and all things: death. When the first stars died, they died violently, in explosions called supernovae, the most energetic events in the universe, short of the Big Bang and gamma ray bursts. The first stars tore themselves apart, flinging their element-rich material across vast distances of space. A single supernova releases more energy in a few seconds than the Sun will release in its entire 10 billion-year lifetime. At the moment of the explosion, the dying star briefly outshines the entire galaxy that contains it. For a few days, one star can equal the light of 100 billion others. These first supernovae seeded the universe with chemistry. For the first time in cosmic history, space was no longer just hydrogen and helium. It was carbon, oxygen, nitrogen, silicon, iron, all the richness of the periodic table scattered across the darkness of space, ready to be gathered by the next generation of gravity, the next generation of stars, the next generation of worlds. Consider what this means. Every supernova is an act of cosmic generosity. Every dying star is a gift to everything that follows. The death of a star is not destruction, it is transformation. It is the universe completing a cycle it has been running for 13.8 billion years, taking simple matter, forging it into complex matter, scattering it across space, allowing it to form into new and more complex configurations. Stars are not incidentally involved in the process of creating complexity. Stars are the process. Stars are what the universe does when it wants to make something new. The most massive of the first stars did not merely explode as supernovae, they collapsed. When a star reaches a certain threshold of mass, roughly 20 times the mass of our Sun, the core at the moment of supernova collapse cannot stop. The gravitational pressure overwhelms every force that might resist it. Protons and electrons are crushed into neutrons. Then the neutrons themselves are crushed, and the core collapses to a point of infinite density, a singularity, a black hole. an object so dense that not even light, traveling at 300,000 kilometers per second, can escape its gravitational grip. Black holes were not discovered by modern science. They were suspected, feared, and mythologized by ancient cultures who had no idea they existed. Every mythology contains a devouring darkness at the center of the cosmos. The Egyptians had Apep, the great serpent of chaos and darkness that devoured the sun each night. The Norse had Nidhogger, the dragon gnawing at the roots of existence. The Hindus had the concept of the cosmic dissolution, the Mahapralaya, in which all things are absorbed back into the primordial darkness. They were all, in their way, describing black holes, the darkness at the heart of creation that devours light, the points where the laws of physics break down, the places where the universe keeps its most forbidden secrets. At the center of nearly every major galaxy in the universe, including our own, there is a supermassive black hole, a darkness of unimaginable scale. And it has been there since nearly the beginning, and it has been watching everything, and it is patient in a way that even time itself cannot measure. As the first stars lived and died, as their explosion seeded space with heavy elements, as black holes formed at the centers of the first stellar clusters, gravity continued its patient, inexorable work. Stellar clusters merged, dark matter halos merged, the first galaxies began to take shape, assembling over hundreds of millions of years from the collisions and mergers of smaller structures. The process was violent. Early cosmic history is a history of collision. Galaxies smashing into galaxies, stars flung like sparks from the impact, new bursts of star formation triggered by the compression of gas in the collision. The universe in its youth was chaotic, turbulent, creative in the way that violence is creative, breaking old patterns to enable new ones. The great galactic structures we observe today, the elliptical galaxies, the spiral galaxies, the galactic clusters and superclusters, were all forged in the fires of merger and collision, assembled across billions of years from the debris of smaller things. Our own galaxy, the Milky Way, assembled over approximately 13 billion years. It began as a small collection of the first stars and dark matter, and grew through merger after merger, consuming smaller satellite galaxies, accumulating more gas and dust, spiraling it all into the elegant disk structure we see today. The Milky Way is not a fixed, permanent thing. It is the current state of a process that has never stopped. A river of stars, 200,000 light-years across, containing somewhere between 200 and 400 billion individual suns, orbiting a supermassive black hole at its center that is 4 million times the mass of our sun. The ancients called the Milky Way by names that reveal their intuition of its true nature. In Greek mythology, it was formed from the spilled milk of the goddess Hera, a river of divine origin flowing across the heavens. In Hindu cosmology, it was the Akasha Ganga, the celestial river Ganges flowing across the sky. The Maori called it Te Ika a Maui, the fish of Maui, a divine creature of cosmic scale. In almost every culture, the band of the Milky Way was recognized as something different from ordinary stars, something vast, ancient, and divine. They were correct. It is vast, it is ancient, and if divinity means anything at all, it belongs to something that creates complexity from simplicity on a scale of billions of years and hundreds of billions of suns. Billions of galaxies, each containing billions of stars, each star burning for billions of years, each year containing millions of moments, each moment containing the entire history that preceded it. This is the architecture of what is. We are standing inside a cathedral built over 13 billion years, and we have only just found the door. Chapter 3. Earth Forged in Fire. The Birth of the World. 4.6 billion years ago. 9 billion years after the Big Bang, in an unremarkable region of the outer third of the Milky Way galaxy's spiral arm, a cloud of gas and dust that had been drifting through space for eons was disturbed, perhaps by the shock wave of a nearby supernova, perhaps by the gravitational tug of a passing star. The cause is lost to time, but the effect was the beginning of everything you have ever known. The cloud began to collapse under its own gravity. As it collapsed, it spun, the way an ice skater spins faster when they pull in their arms. It flattened into a disk. At the center of the disk, material concentrated and compressed until the temperature exceeded 15 million degrees Celsius and hydrogen fusion ignited. A new star was born, a modest star by cosmic standards, medium mass, medium temperature, medium brightness, a yellow dwarf star that would be classified in any astronomer's catalog as utterly ordinary. We call it the Sun. Around the newborn Sun, the remaining disk of gas and dust began to interact. Particles collided and stuck together. Clumps formed. Clumps merged into larger clumps. The larger clumps had more gravity and swept up more material. Over millions of years, the disk cleared, not because it dispersed, but because it had organized itself into a series of bodies large enough to dominate their orbital zones, the planets. And among them, at a distance from the Sun that would prove to be one of the most significant accidents in the history of the cosmos, a rocky world that we call Earth. Earth did not form quietly. It formed through violence of a kind that staggers imagination. The early solar system was a shooting gallery. Billions of rocks, from pebbles to mountain-sized boulders to bodies hundreds of kilometers across, called planetesimals, filled the space between the orbits of the newly forming planets. They crashed into each other constantly. The impact events that occasionally strike modern Earth, the events that kill species and reshape continents, were not catastrophes in the early solar system. They were the normal state of affairs. Earth was being assembled by collision, layer by layer, impact by impact, over millions of years. Earth did not arrive in the cosmos. Earth was made, hammered together from the debris of dead stars, assembled by gravity and violence, cooked in the furnace of collision until something extraordinary emerged from the chaos, a world capable of hosting the impossible experiment called life. The young Earth was nothing like the world we know. It was a world of magma and fire. The heat generated by all those impacts, combined with the heat of radioactive decay in its interior, kept the surface molten for millions of years. There was no crust, no continents, no ocean, just a global ocean of liquid rock, glowing red-orange in the light of a sun slightly dimmer and slightly redder than the one we see today. If you could somehow have stood at the edge of this world, which you could not because there was no solid surface to stand on, the sky above would have been thick with an atmosphere of steam and carbon dioxide and sulfur dioxide, glowing orange from below with the light of the magma, thick and choking and absolutely hostile to the faintest possibility of life. And then an impact so catastrophic that it changed the Earth forever, changed it in a way that would ultimately make life and humanity possible. A body approximately the size of Mars, a protoplanet that scientists have named Theia after the Titan, mother of the moon in Greek mythology, was on a collision course with the young Earth. The probability of such a collision was not small. In the chaotic early solar system, such encounters were the mechanism by which planets grew. Theia had been drifting in an orbital resonance with Earth, gradually destabilized by gravitational perturbations from the other forming planets until its orbit crossed Earth's. The two worlds met. The impact was not a clean, head-on collision. Theia struck at an oblique angle, a glancing blow that vaporized much of both bodies' outer layers. The force of the impact was so enormous that vast quantities of molten and vaporized rock were hurled into orbit around the surviving merged planet. And from that debris ring, over thousands of years, the moon coalesced. Our moon, the companion that rules our tides, that stabilizes the tilt of our rotational axis, that lit the nights of our ancestors and drove the calendars of every civilization that has ever existed, was born from the worst impact Earth has ever suffered. The moon is not an accident. It is a scar, the most beautiful and consequential scar in the solar system. Without the moon, Earth's axial tilt would wobble chaotically over millions of years, creating climate swings so extreme that the stable, long-term environments in which complex life evolved might never have persisted. The moon is part of why life was possible here. The catastrophe that created it was part of the sequence of necessary violence that prepared this world for what came next. Every ancient culture that saw the moon understood it as divine. The Mesopotamians called it Sin, the god who counted the days and governed destiny. The Egyptians had Thoth, the lunar god of wisdom and time. The Greeks had Selene, then Hecate, the moon as a triple goddess, growing, full, and dying in an eternal cycle. The Norse had Mani, chased across the sky by the wolf Hati. In the Maya calendar, the moon was a fundamental driver of ritual time. They were all looking at the same thing we are looking at, a world born from catastrophe, orbiting in perfect silence, governing tides and seasons and the rhythms of life, a constant reminder that beauty and violence are not opposites. They are partners in creation. Between approximately 4.1 and 3.8 billion years ago, something disrupted the outer solar system. The giant planets, Jupiter and Saturn, shifted their orbits slightly due to gravitational resonances with each other, and this shift sent a wave of destabilization through the asteroid belt and the Kuiper belt beyond Neptune. The result was the Late Heavy Bombardment, a period of intensified meteor and comet impacts across the entire inner solar system. The moon's cratered face is the record of this bombardment, preserved in its airless, geologically dead surface for billions of years. Earth was hit too, hit harder and more often, given its larger gravitational target, but Earth's geological activity has erased most of the scars. There is a terrible irony in the late heavy bombardment. The same catastrophic rain of cosmic debris that was pulverizing the early Earth was also delivering something vital: water. Comets, those frozen travelers from the outer solar system, carried enormous quantities of ice. Some fraction of Earth's oceans, perhaps a significant fraction, arrived from space during this bombardment. The violence that was trying to sterilize the early Earth was simultaneously giving it the ingredient most essential for life. The cosmos has always worked this way. It gives and destroys with the same hand. By 3.8 billion years ago, the bombardment had faded. The solar system had settled into something more stable, not peaceful, never truly peaceful, but less actively catastrophic. And on the surface of the young Earth, in the heat of hydrothermal vents at the bottom of a shallow, warm ocean, something was beginning to happen. Something that makes the formation of the solar system look simple by comparison. Something that no scientist has fully explained, that no mythology has adequately mythologized, that remains, to this day, the deepest mystery in all of science. Life was beginning. Earth remembers what humanity forgot. It remembers the fire at its heart. It remembers the rock that broke it open. It remembers the ice that made it weep its first oceans. It holds these memories in stone, in the slow drift of continents, in the heat that still rises from its core. The world beneath our feet is not ground, it is memory. Chapter 4. Oceans that dreamed of life. The origin of life, 3.8 billion years ago. Abiogenesis, the impossible transition. There is a question at the heart of biology that chemists approach with humility, that philosophers approach with vertigo, and that the ancient mythologists approached with complete certainty. How did life begin? How did chemistry become biology? How did matter, following nothing but the laws of physics, organize itself into structures capable of growth, reproduction, response to environment, and eventually consciousness? We do not fully know. This is the honest answer, and it is one of the most important honest answers in all of science. We know a great deal about the conditions of the early Earth. We know the chemistry that was possible. We know that certain types of molecules, RNA in particular, or RNA-like precursors, can perform both the genetic information storage and the catalytic functions that life requires. We know that hydrothermal vents provide concentrated energy and mineral gradients that could have driven the first chemical reactions towards self-organization. We know that organic molecules, including amino acids, can form spontaneously in the conditions of the early Earth, and that they arrive on Earth from space in meteorites. We have solved many of the sub-problems of life's origin, but the full picture, the moment when a collection of self-replicating molecules first crossed the threshold into something that deserves to be called alive, that moment remains shrouded in mystery. It may be the single greatest mystery in the history of science, because what happened was not just improbable. What happened was the universe crossing a threshold from which it would never return. Before life, the universe was physics and chemistry. After life, the universe was something else entirely, something that could want, something that could fear, something that could, billions of years later, look up at the stars and wonder where it came from. Every creation myth in human history is an attempt to describe this moment, the moment when matter became aware of itself. And every creation myth is incomplete, because this moment is still not fully understood, because this moment may be, in some fundamental sense, beyond the reach of the kind of understanding that does not itself require life to do the understanding. The earliest evidence of life on Earth dates to approximately 3.5 to 3.8 billion years ago. Stromatolites, layered rock structures built by microbial mats of cyanobacteria and other microorganisms, have been found in ancient formations in Western Australia, the Nuvualagtuk Belt in Canada, and elsewhere. They are the most ancient monuments on Earth. They predate every other structure, natural or human-made, by an almost incomprehensible margin. They are older than any mountain range that currently exists. They are older than any ocean basin in its current form. They are older than most of the continental crust. They are, in the most literal possible sense, the first architecture that life ever built. And what were these earliest organisms? Prokaryotes. Single-celled entities without a nucleus, without membrane-bound organelles, without the complex internal machinery of the cells that make up your body. They were, by any modern biological standard, extraordinarily simple, and yet they were life. They consumed chemical energy. They reproduced. They mutated. They competed. They evolved. In their simplicity, they contained the entire possibility space of everything that would come after. Every dinosaur, every whale, every eagle, every oak tree, every human being who has ever lived or thought or loved, all of it was potential in those first microbial mats at the bottom of the Archean Ocean. The Great Oxidation Event, when life changed the world. For more than 1 billion years, a span of time longer than the entire subsequent history of complex life, life on Earth was exclusively microbial. The world was ruled by bacteria and archaea. And in that seemingly uneventful span of deep time, something was being prepared, something that would ultimately transform the planet and make all subsequent life possible. Approximately 2.4 billion years ago, cyanobacteria, the single most consequential life forms in the history of this planet, had evolved the ability to perform oxygenic photosynthesis, to use sunlight to split water molecules and release oxygen as a byproduct. And over hundreds of millions of years, the cumulative oxygen production of billions upon billions of cyanobacteria slowly, inexorably transformed the atmosphere of Earth. Before the Great Oxidation Event, Earth's atmosphere was dominated by nitrogen, carbon dioxide, methane, and various sulfur compounds. Oxygen was essentially absent. After the Great Oxidation Event, free oxygen began to accumulate in the atmosphere and oceans, reaching levels approaching modern concentrations over the following 2 billion years. For most life on Earth at the time, this was an apocalypse. Oxygen is a powerful oxidant, a reactive, corrosive gas that destroys organic molecules and disrupts the chemistry of anaerobic organisms adapted to an oxygen-free world. The Great Oxidation Event killed an enormous fraction of the life that existed at the time. It was, by some measures, the greatest mass extinction in the history of the planet, a planet-scale catastrophe caused not by asteroid impact or volcanic eruption, but by the metabolic waste product of a microorganism. And yet, it was also the greatest gift that life has ever given itself, because oxygen, that same corrosive, deadly gas, is also the most energy-efficient fuel for cellular metabolism that chemistry has to offer. Aerobic respiration, the process that uses oxygen to extract energy from organic molecules, is roughly 18 times more efficient than anaerobic respiration. The organisms that could exploit oxygen had access to a metabolic windfall. And that metabolic windfall, that explosion of available energy, eventually powered the evolution of complex multicellular life, of animals, of everything that followed. The ancient mythologies that spoke of a primordial catastrophe that cleared the world for new creation were not merely being poetic. They were describing, in mythological terms, a pattern that the history of life on Earth has repeated over and over: catastrophe as prerequisite for transformation. The Great Oxidation Event, the late heavy bombardment, the Chicxulub impact. Every great catastrophe in the history of life has been followed by a flowering of new forms. The universe seems to require periodic destruction as part of its creative process. The mythological impulse to see death and rebirth as a divine cycle is not superstition, it is observation. The endosymbiotic revolution. Cells eating cells, becoming something new. Approximately 2 billion years ago, something extraordinary happened inside a cell. An archaeocell engulfed a bacterium. This had happened trillions of times in the history of life. Predation and engulfment are as old as the first predators. But this time, something different occurred. The engulfed bacterium was not digested. It survived. It took up permanent residence inside the archaeocell, and over generations, it became something entirely new, a mitochondrion. This event, described in the theory of endosymbiosis, developed by the brilliant and initially ridiculed biologist Lynn Margulis, was the origin of all complex life on Earth. Every cell in your body contains mitochondria. Every animal, every plant, every fungus, every protozoan, every eukaryote, every organism with a cell nucleus descends from that ancient merger of two separate organisms into one. Your cells are literally the descendants of a colony. Your biology is the result of cooperation so deep and so old that the original partners have been inseparable for 2 billion years. Think about what this means. You are not one organism. You are many. At the cellular level, at the mitochondrial level, at the microbiome level, you are a community. Ancient Egyptian theology had a concept called the Ka, a spiritual double that resided within the body as a separate but inseparable entity. The Greek pneuma, the animating breath that was both within and beyond the physical body. The Vedic concept of the individual Atman as simultaneously distinct from and identical to the universal Brahman. These metaphysical intuitions that the self is both one and many, both distinct and merged, both individual and cosmic, are not wrong. They are, at a deeper level of biology than their originators could have imagined, precisely correct. You carry within each cell an ancient bacterium that became part of you 2 billion years before your ancestors were born. Life did not merely evolve on this planet. Life merged, collaborated, and became something greater than its components. The universe's deepest creative strategy is not competition alone. It is the formation of the new through the union of the old. The age of monsters, the Cambrian explosion through the Mesozoic, 541 to 66 million years ago. The Cambrian explosion, 541 million years ago. For 3 billion years, life on Earth had remained essentially microscopic: bacteria, archaea, protozoa, algae. The most complex organisms were simple colonies of cells, and even the first true multicellular animals, soft-bodied ediacaran creatures that appeared perhaps 600 million years ago, were strange, passive, almost plant-like things, frond-shaped, disc-shaped, alien to modern eyes, stranger than anything in any ocean today. Life had been patient and simple for a span of time that makes the entire subsequent history of complex animals seem like an afterthought. And then, in a period that geologists call the Cambrian explosion, something happened that has puzzled and fascinated scientists ever since Darwin first noted it with concern in The Origin of Species. In a geological instant, roughly 20 to 25 million years, which is fast on geological timescales, the fossil record blossoms. Suddenly, almost every major body plan that has ever existed in the animal kingdom appears. Eyes, legs, shells, jaws, claws, spines, gills. Body plans representing dozens of phyla appear in the Cambrian record with little or no obvious precursor. It is as if the history of complex animal life was waiting, patient as the universe itself, for a trigger, and then something pulled it. What triggered the Cambrian explosion is still debated. Increasing atmospheric oxygen, a snowball Earth glaciation that preceded it, which may have intensified evolution through population bottlenecks. The evolution of predation, which created an arms race between predators and prey that drove rapid evolutionary innovation on both sides. Perhaps a combination of all of these, but the effect was undeniable. The oceans of the Cambrian were more diverse, more complex, and more spectacular than anything that had existed in the preceding 3 billion years of life. The Cambrian seas contained creatures that look, to modern eyes, like the products of hallucination. Anomalocaris, a top predator half a meter long, enormous by Cambrian standards, with compound eyes, a circular jaw of overlapping plates, and grasping appendages that swept small creatures into its mouth. Hallucigella, a many-legged creature with spines along its back, whose body plan so defied categorization that early paleontologists placed its fossil upside down and described the spines as legs. Opabinia, with 5 eyes and a proboscis tipped with a claw. Wiwaxia, covered in overlapping scaly armor. Picaia gracillans, a small, humble, worm-like creature with a notochord, possibly the earliest known ancestor of all vertebrates, including us. Look at the creatures of the Cambrian seas and understand something important. The body plan you inhabit, your bilateral symmetry, your spinal cord, your eyes, your limbs, these are not the inevitable products of evolution. They are one solution among dozens that were tried and mostly abandoned in the great experiment of the Cambrian. You are a survivor of a lottery that killed far more imaginative designs than it preserved. The Devonian, when life conquered the land. The oceans had been the cradle of complex life for hundreds of millions of years, but approximately 420 million years ago, life began to make the most audacious transition in its history since the origin of multicellularity, the move onto land. The first conquerors were plants, relatives of modern mosses and liverworts, that colonized the wet margins of continents and began the slow transformation of barren rock into soil. They were followed by fungi, the great decomposers and nutrient recyclers, without which soil ecology is impossible. And then, eventually, by animals. The fish that crawled onto land, a transition documented in the remarkable fossil series from Tiktaalik rosei and its relatives, were not trying to become land animals. They were lobe-finned fish, using their muscular fins to drag themselves through shallow water and muddy bottoms, possibly in search of prey or escape from aquatic predators. The limbs that would eventually carry their descendants across continents were originally just tools for navigating shallow environments. Evolution does not plan, it improvises. It takes what is available and repurposes it. The fin became the leg. The swim bladder became the lung. The gill arch became the jaw, the ear, the hyoid bone in your throat. The first true land animals, the early tetrapods of the late Devonian, stepped onto a world already transformed by the plants and fungi that had preceded them. They found a world of dense, swampy forests of giant club mosses and ferns, strange and alien to modern eyes, full of creatures trying to exploit this new ecological frontier. Insects had preceded the vertebrates onto land and were already diversifying rapidly. Some would evolve to enormous sizes in the oxygen-rich atmosphere of the Carboniferous, dragonflies with wingspans of 60 centimeters, millipedes 2 meters long. A world that would have seemed to any modern human like a fever dream, like the landscape of a myth. The Age of Reptiles, the dinosaurs. 250 million years ago, a catastrophe unlike anything since the Great Oxidation Event reset the trajectory of life on Earth. The Permian-Triassic mass extinction, the worst extinction event in the history of complex life, killed approximately 96% of all marine species and 70% of all terrestrial vertebrate species. The cause was the eruption of the Siberian Traps, a volcanic episode so prolonged and so massive that it flooded vast areas of what is now Siberia with lava and, more devastatingly, pumped enough carbon dioxide, sulfur dioxide, and methane into the atmosphere to trigger runaway greenhouse warming, ocean acidification, and oxygen depletion in the seas. Life very nearly ended. the biosphere came closer to total collapse 252 million years ago than at any other time in its history. From the survivors of the Permian extinction, a new world assembled itself. The Mesozoic era, the age of reptiles, the age of dinosaurs, was unlike anything before or after. A world warmer than today, with no polar ice caps, with shallow tropical seas covering vast areas of what are now continents, with a supercontinent slowly rifting apart into the configuration we know today. And ruling this world from approximately 230 million years ago until 66 million years ago, the most famous animals in the history of life, the dinosaurs. The word dinosaur has become so familiar, so encrusted with cultural associations, children's toys, museum fossils, movie monsters, that we have lost the capacity to be properly astonished by them. But consider, for 165 million years, dinosaurs dominated virtually every large terrestrial ecological niche on Earth. The largest animals that have ever walked on land were dinosaurs, sauropods like Argentinosaurus and Patagotitan, whose bodies could exceed 70 tons, whose necks stretched 15 meters, whose footfalls shook the ground for hundreds of meters. Animals so large that no modern organism comes close. Animals whose physiology we are still arguing about, whose behavior we are still decoding, whose full diversity we are still discovering. And they were not the lumbering, cold-blooded reptiles of early imagination. Modern paleontology has revealed them as dynamic, warm-blooded, or at least partially so, often feathered, often brightly colored, cognitively sophisticated animals. Some were pack hunters. Some showed evidence of parental care. Some had crests and frills and elaborate displays that suggest complex social and reproductive behavior. The Jurassic and Cretaceous were not the silent alien worlds of old textbooks. They were worlds full of animals that communicated, competed, formed social groups, raised their young, and navigated complex ecological webs. They were alive in ways that the earliest reconstructions of them never captured. And threaded through the dinosaur world, small and humble and mostly nocturnal, forced by competition to develop larger brains and more acute senses to survive in the margins that the dinosaurs left unoccupied, a group of small, furred, warm-blooded creatures, the early mammals, your ancestors. For 165 million years, your ancestors were prey. They were small, they were timid, they lived in burrows and trees, emerging at night to avoid the reptilian giants that owned the daylight world. Everything that came later, every civilization, every philosophy, every work of art or act of love or war that humanity has ever committed was possible only because those tiny, trembling creatures survived the age of the dinosaurs by staying small and staying hidden. They were not the giants of that world. They were not the conquerors. They lived in the gaps, in the shadows, in the dark spaces between the great ones. And they watched, and they learned, and they waited, for something was coming from the sky. Chapter 6. When the Sky Brought Death. The Chicxulub Impact. 66 million years ago. T-0. The final morning. 66 million years ago, the world that existed was, by any measure, extraordinary. The Cretaceous was reaching the peak of its diversity. Tyrannosaurus rex had reached its full terrifying form. Triceratops roamed the Hell Creek floodplains in vast herds. Mosasaurs the size of school buses patrolled the shallow Cretaceous seaway that divided North America. Tyrannosaurs with wings spanning approaching 12 meters soared on the warm updrafts above shallow tropical seas. Angiosperms, Flowering plants had recently diversified into thousands of species and were transforming the visual landscape of the world into something almost recognizable by modern eyes. Flowers, forests, color. The insects that co-evolved with them were diversifying in parallel. The world was rich, complex, interconnected, and in dynamic equilibrium. No organism on that last Cretaceous morning had any warning of what was coming. There was no prophet, no celestial sign, no ancient prophecy. The cosmic mechanism that would end the Cretaceous world and make way for ours was a rock roughly 12 to 15 kilometers in diameter, the size of a city, a member of the asteroid belt destabilized from its orbit perhaps millions of years earlier by the gravitational influence of Jupiter and Mars, falling on a trajectory that no living creature on Earth had the capacity to detect. It hit. At approximately 30,000 kilometers per hour, it struck what is now the Yucatan Peninsula of Mexico, then a shallow tropical sea. The impact released energy equivalent to approximately 10 billion Hiroshima atomic bombs. In a fraction of a second, the asteroid and a vast quantity of the surrounding seafloor and continental rock were vaporized. A plume of superheated gas and pulverized rock shot through the atmosphere and into space. Tsunami waves, hundreds of meters tall, radiated outward across the Caribbean and the Gulf of Mexico. The impact created a crater 180 kilometers across and 20 kilometers deep, one of the largest impact structures on Earth. The immediate devastation was local but enormous. Everything within perhaps 1,000 kilometers of the impact was killed almost instantly by the heat and the blast. But the secondary effects, the effects that killed the dinosaurs, were global. The vaporized rock created a massive injection of sulfate aerosols into the upper atmosphere, blocking sunlight and causing global temperatures to plummet. Wildfire smoke from fires ignited by re-entering ejecta added to the atmospheric pall. The impact winter that followed lasted years. Photosynthesis collapsed. The food chains that depended on it collapsed. The herbivores died. The carnivores that ate the herbivores died. 75% of all species on Earth went extinct in what geologists call the KPG boundary, the line in the rock record where the Cretaceous ends and the Paleogene begins. The sky brought death. The oldest human fear, the fear of something falling from the sky, the fear of fire from heaven, the fear of celestial judgment, is not primitive superstition. It is species memory. Homo sapiens carries in its mythology the echo of what the universe does to worlds that become too comfortable. Our ancestors felt it in their bones, though they did not know why. They built temples and made sacrifices and implored the sky for mercy. They were not wrong to be afraid. Every mythological tradition in human history includes some narrative of cosmic catastrophe, a great flood, a rain of fire, a falling of the stars, a divine judgment that killed most of the world and from which only a remnant survived. The Babylonian Atrahasis and Gilgamesh flood epics, the Hebrew Noah, the Hindu Manu, the Greek Deucalion, the Norse Ragnarok, the Maya Popol Vuh's series of creations and destructions. Scholars debate the origins of these myths, whether they preserve genuine memories of catastrophic events, whether they reflect universal psychological patterns, whether they were transmitted through ancient cultural contacts. The truth may be simpler and stranger than any of these explanations. It may be that the fear of cosmic catastrophe is encoded in our biology, that evolution, having placed our lineage in a world that has been catastrophically reset multiple times, has given us a nervous system primed to imagine the worst from above. We are, in a very real sense, the children of catastrophe. Humans exist because the Chicxulub impactor fell. The small insectivorous nocturnal mammals that survived the KPG extinction survived precisely because they were small enough to survive on whatever food remained during the impact winter, small enough to hide underground, small enough to need little energy. The dinosaurs, magnificent and dominant and ancient, were too large, too specialized, too dependent on the rich Cretaceous food web to survive its collapse. When the world they had built was destroyed, they could not adapt. But the small, humble, frightened mammals, they could. They did. And from them, over the next 66 million years, came everything that followed. The Paleocene dawn, a new world from the ashes. The world that emerged from the KPG mass extinction was impoverished. The forests were gone, the large animals were gone. The sky was dark and cold, but the seeds were still there. The spores were still there. The small surviving animals were still there. And slowly, over tens of thousands of years, then millions, the world rebuilt itself. The Paleocene was not the Cretaceous. The species that dominated it were different. The ecological niches vacated by the dinosaurs were now open, waiting. And the mammals, freed at last from 165 million years of secondary status, freed from the necessity of smallness and hiddenness, began to experiment. The mammalian radiation of the Paleocene and Eocene was one of the most spectacular evolutionary events in the history of life. In just tens of millions of years, an eye blink in geological time, mammals diversified into virtually every ecological niche that the dinosaurs had vacated and many that had never been exploited before. Whales evolved from land mammals and returned to the sea. Bats took to the air. Horses, elephants, rhinoceroses, primates, rodents, carnivores, the entire modern mammalian fauna assembled itself from the survivors of the impact. The world that emerged from catastrophe was not a diminished world. It was, in some respects, a more diverse and more dynamically evolving world than the one that preceded it. Among the survivors and their descendants in the forest margins of the Eocene and Oligocene epochs were small arboreal creatures with grasping hands, forward-facing eyes, and unusually large brains relative to body size. Primates, the order to which we belong. The creatures that, over the next 30-odd million years, would diversify, specialize, come down from the trees in Africa as the forests shrank and the savannas expanded, and begin the journey, improbable, contingent, necessary in retrospect, toward the species that would one day build telescopes to look back at the asteroid that made them possible. The sky brought death, but from the ruins something stirred, something small, something warm, something frightened, something that had been waiting in the margins for 165 million years. Its eyes opened wider in the sudden light. It looked around at the empty world and did not yet know what it would become. Chapter 7. The Creatures Who Looked Up. The Rise of Humanity, 7 million to 300,000 years ago. The Divergence, 7 million years ago. Somewhere in Africa, approximately 5 to 7 million years ago, the lineage that would eventually produce Homo sapiens diverged from the lineage that would produce our closest living relatives, the chimpanzees. The precise cause of this divergence is still debated, though the most compelling hypothesis involves the geological and climatic transformation of East Africa as the Great Rift Valley formed. A vast tectonic wound opening in the continent's crust, changing rainfall patterns, shrinking forests, and expanding the open savannas. The forest-dwelling ape ancestors of both lineages were divided by this expanding landscape. Those on the western side, where forest persisted, became the ancestors of chimpanzees and bonobos. Those on the eastern side, facing the expanding savanna, began adapting to a very different world. Bipedalism, upright walking on two legs, was the first and most consequential adaptation of our lineage. It is, biomechanically, a strange and in many ways inefficient way to locomote. Quadrupedal mammals are generally faster, more stable, and less prone to back injuries than bipeds. The advantages of upright walking are indirect. It frees the hands for carrying and tool use. It elevates the head for better visibility across tall grass. It is more energy efficient over long distances on open ground, and it allows heat dissipation through an upright posture that maximizes airflow across the body in the equatorial sun. Upright walking did not make our ancestors immediately more dangerous. It made them more versatile, more adaptable, more capable of exploiting the new, challenging world of the savanna. The early hominins, Australopithecus and its relatives, walked upright but had small brains and large, robust jaws and teeth suited for a diet that included tough plant material. They were not us. They were something between the forest ape and the open country hunter, transitional forms that the fossil record preserves like pressed flowers, flat and informative, and suggestive of what they were becoming. They used some tools, simple sharp-edged stones probably, but the sophistication of their technology was minimal. They were smart animals. They were not yet thinking animals in the sense that matters most. Homo erectus, fire and the world walk. Approximately 2 million years ago, a new species emerged in Africa. Homo erectus, taller, with a brain significantly larger than any earlier hominin, with hands capable of more refined manipulation, and, crucially, with the ability to control and use fire. The use of fire is, in the history of life on Earth, one of the most significant technological developments that has ever occurred. No other animal has ever mastered it. No other animal has ever used it to transform itself as our ancestors used it. Fire meant cooked food, and cooked food means more digestible, more nutritious, and more calorie-dense meals, which freed energy for the single most metabolically expensive organ in the animal kingdom, the human brain. Fire meant warmth in cold climates, which meant the ability to expand into environments that would otherwise have been inaccessible. Fire meant light in the darkness, which meant the ability to work, socialize, and organize during the night hours when predators hunted. Fire meant protection. Few predators willingly approach fire. Fire was the first technology that transformed not just what our ancestors could do, but what they were. The investment of metabolic energy into the brain that fire enabled was self-reinforcing. Smarter individuals could use fire more effectively, could cooperate more effectively, could communicate more effectively, and had more offspring, and so the brain grew larger and the intelligence grew deeper over the next 2 million years. Homo erectus did something remarkable that no earlier hominin had done. It left Africa. Between approximately 1.8 and 1 million years ago, Homo erectus populations expanded out of Africa and into Eurasia, into the Caucasus, into Central Asia, into South and Southeast Asia, all the way to what is now Java and perhaps further. They did this in a world of megafauna, lions, mammoths, cave bears, giant hyenas, saber-toothed cats that were far more powerful than any individual human. They succeeded because they were social. They hunted cooperatively. They communicated. They accumulated and transmitted knowledge across generations. They were, in embryonic form, the culture-bearing species that would eventually cover the world. Homo sapiens, the species that imagined. Between approximately 300,000 and 200,000 years ago in Africa, Homo sapiens emerged, our species, the species that would inherit the Earth that the asteroid cleared, the species that the star's supernovae had salted with the elements for, the species that the 3 billion-year experiment of evolution had been, unknowingly, undirectedly, but with the full force of deep time, preparing for. We were not inevitable. No single species ever is, but we were possible. And the universe, or at least the local portion of it we call Earth, had been creating the conditions for our possibility since the first oxygen molecules entered the atmosphere, since the first fish fin became a leg, since the first mammal sheltered from the cold under a warm sky. What made Homo sapiens different from all previous hominins was not primarily physical, it was cognitive. Modern humans have a capacity for symbolic thought, the ability to represent things that are not physically present, to imagine things that do not yet exist, to communicate abstract concepts through language that exceeds anything in the prior history of life. This capacity manifested in art, in music, in ritual, in the construction of belief systems about the nature of reality, in the making of tools not just for survival, but for expression, in the telling of stories. The oldest known cave art dates to approximately 45,000 years ago. Hand stencils, animal paintings, geometric marks. But the cognitive hardware for symbolic thought was almost certainly in place much earlier, perhaps from the origin of our species. A piece of ochre from Blombos Cave in South Africa, dated to approximately 75,000 years ago, bears deliberately engraved geometric patterns, the oldest abstract art yet found. Beads made from shells, perforated with apparent intention, have been found at sites in North Africa, dating to 130,000 years or more. The capacity to make something beautiful, to mark a surface not for any practical purpose, but because the pattern itself was meaningful, is among the most mysterious and most significant abilities in the history of life. No other species makes art. No other species tells stories about where it came from and where it is going. No other species builds models of the universe in its mind and then tests those models against reality. The species that emerged from the African savanna 300,000 years ago was not merely a better adapted primate. It was something qualitatively new in the history of life on this planet, a being that could conceive of its own existence and ask whether existence itself had a meaning. Chapter 8. Temples Beneath the Stars. The Age of Civilization, 70,000 to 2,000 years ago. The Great Journey Out of Africa. Approximately 70,000 years ago, something happened that changed the trajectory of human history in ways that may never be fully explained. A population of Homo sapiens, perhaps as few as a few thousand individuals, left Africa and began to expand across the world. They moved through the Levant and into the Middle East. They followed the coasts of Asia eastward. They reached Southeast Asia, and some crossed the water to Australia, the earliest seafarers in human history, reaching a continent whose megafauna had never encountered bipedal hunters, with devastating results. They moved northward into the Eurasian heartland. They crossed the land bridge of Beringia into the Americas, perhaps 20,000 to 15,000 years ago. Within a few tens of thousands of years, the blink of an eye in geological time, Homo sapiens occupied every continent on Earth, every climate zone, every ecological niche, from Arctic tundra to tropical rainforest to high-altitude plateau to desert. The migration was accompanied by what is sometimes called the cognitive revolution, a flowering of cultural and technological innovation that left unmistakable traces in the archaeological record. Cave paintings of extraordinary sophistication and beauty in Chauvet and Lascaux and Altamira. Carved figurines, including the famous Venus figurines found across Eurasia, some dating to more than 35,000 years ago. sophisticated multi-component tools, not just stone flakes, but hafted spears, bows, needles for sewing warm clothing, musical instruments, burial rituals with grave goods, the marks of a species that had begun to live in the world of ideas as much as the world of matter. And everywhere they went, our ancestors looked up at the same sky and saw the same stars and felt the same awe that we feel today. The stars were not merely lights in the sky. They were the most important information technology available to a species without writing. The movements of stars and constellations told the time of year, guided navigation, predicted the seasons, marked the cycles of planting and harvesting and the movements of game. The sky was the first calendar, the first map, the first book. And the people who could read it most accurately, the shamans, the priests, the astronomers before astronomy, were among the most socially powerful members of their communities. Göbekli Tepe, the world's first temple. Approximately 11,600 years ago, at a site in what is now southeastern Turkey, human beings built something that should not have existed. Göbekli Tepe, the Potbelly Hill, is a complex of carved stone pillars, some weighing up to 20 tons, arranged in circles, covered in bas-relief carvings of animals and abstract symbols. The complexity and scale of the construction demands not just technical capability, but social organization, the ability to coordinate hundreds of workers, to feed them and house them, to plan and execute multi-year construction projects. And it predates the invention of agriculture, the conventional starting point for the level of social organization it requires, by perhaps 1,000 years. Göbekli Tepe may have been a temple, a place of ritual and ceremony rather than habitation. The archaeologist who first excavated it, Klaus Schmidt, proposed something radical, that it was religion, specifically the need for a monumental sacred space that created the conditions for civilization, rather than civilization creating the conditions for religion. That the gatherings of hunter-gatherer peoples at this site, perhaps for feasts and rituals centered on the stars and the seasons, created the first social networks complex enough to require grain storage, which required agriculture, which required permanent settlement, which became the first towns. The stars were the first gods, and the worship of those gods may be the reason we are civilized. The awe that our ancestors felt when they looked at the night sky was not merely an emotion, it was a force in history. It drove the construction of the first great monuments. It drove the first systematic observations of nature. It drove the first philosophical questions. It drove, ultimately, the development of science. The path from the stone circles of Göbekli Tepe to the radio telescopes of the Very Large Array runs through an unbroken tradition of humans looking at the sky and asking, "What is that? What does it mean? How can I know?" The agricultural revolution, the world transformed. Between approximately 12,000 and 10,000 years ago, in multiple locations across the globe, the Fertile Crescent, the Yellow River Valley, the highlands of New Guinea, the Andes, Mesoamerica, Sub-Saharan Africa, humans independently discovered or developed agriculture. The domestication of plants and animals was not a single event, but a long process, spanning thousands of years, driven by gradual selection for more productive, more manageable varieties of wild species. Wheat and barley in the Levant, rice and millet in China, maize in Mesoamerica, potatoes in the Andes. In each case, the transition from foraging to farming changed everything. Agriculture required permanent settlement. Permanent settlement required social hierarchies, specialization of labor, the accumulation of surplus, the construction of storage facilities and defensive walls, the development of writing to keep records. Jericho is among the oldest known permanently inhabited towns, with evidence of continuous occupation stretching back more than 11,000 years. Çatalhöyük in Anatolia, occupied from approximately 7,500 to 5,700 BCE, housed perhaps 8,000 people in a dense, labyrinthine settlement without streets, where inhabitants moved across rooftops and descended into their homes through holes in the ceiling. Uruk in Mesopotamia, by 3000 BCE, had grown to perhaps 40,000 to 80,000 inhabitants, the first city in human history by most definitions. Writing was invented independently in at least 3 places: Sumer in Mesopotamia by approximately 3200 BCE, Egypt at approximately the same time, and China by approximately 1200 BCE. Mesoamerica may have independently developed it as well. The invention of writing is one of the most consequential events in human history, perhaps second only to the agricultural revolution and the industrial revolution in its long-term effects. Writing allowed the storage and transmission of information across time in ways that oral tradition alone cannot achieve. It allowed laws to be codified and consistently applied. It allowed trade to be conducted across distances too large for personal relationships to maintain. It allowed the accumulated knowledge of one generation to be preserved perfectly for the next. It allowed, eventually, science. On December 24, 1968, astronaut William Anders, orbiting the moon aboard Apollo 8, looked out his window and saw the Earth rising above the lunar horizon. He took a photograph, Earthrise. The photograph shows a small blue sphere, luminous, delicate, improbably beautiful, floating above the gray desolation of the moon against the absolute black of space. There is nothing else in the frame, no other light, no other color, just the Earth, the world that took 4.6 billion years to make. The world that sheltered the first life for 3.8 billion years. The world that produced, through extinction and catastrophe, an endless experiment, a species capable of leaving it and looking back. When humanity first saw the whole Earth from space, something changed. Something that had been building since the first Homo sapiens looked up at the stars finally came full circle. The creatures who looked up had looked up far enough to see themselves. The question asked in caves and temples and libraries for 100,000 years had acquired for the first time a visual answer. We are here, small, fragile, alone in the visible frame, but here, unimaginably, improbably, cosmically improbably, here. The present moment, the edge of the known. We're living right now at one of the most extraordinary moments in the history of this planet. More is known about the universe today than was known at any prior point in human history, by orders of magnitude. We have mapped the cosmic microwave background with enough precision to read the quantum fluctuations of the first fraction of the first second. We have detected gravitational waves, ripples in space-time from the collision of black holes and neutron stars a billion light-years away, confirming a prediction Einstein made in 1916. We have imaged the supermassive black hole at the center of M87 galaxy and the one at the center of our own Milky Way. We have discovered thousands of exoplanets, worlds orbiting other stars, and determined that such worlds are not exceptional but are the norm. Nearly every star in the sky likely has planets. Many of those planets are in habitable zones of their stars. We are not alone in having a world. Whether we are alone in having life, or having complex life, or intelligent life, or civilized life, we do not yet know. The Fermi paradox, The observation that a universe this old and this large and this hospitable to worlds should, by most calculations, be teeming with civilizations, and yet we have found no evidence of any, remains unanswered. Are we early? Are we rare? Are we surrounded by intelligences too alien or too distant to detect? Is the universe silent because every civilization that reaches our level of technology eventually destroys itself? We do not know. The answer, when it comes, if it comes, may be the most important piece of information our species has ever received. We are also, for the first time in history, capable of being an existential risk to ourselves, not merely through nuclear weapons, though that risk remains real, but through climate change, through engineered pathogens, through the potential future power of artificial intelligence systems that may exceed human cognitive capacity in ways we have not yet fully imagined. The same intelligence that allowed us to understand the cosmos has given us powers that our wisdom has not yet grown to match. We are a species in the most dangerous phase of our development, capable of great things, capable of terrible things, not yet sure which we will choose. We are the universe examining itself. We are the cosmos asking whether it has a purpose. We are 13 billion years of creation arriving at a moment of decision. What we do next will be remembered, or it will not be remembered at all. Chapter 10. The Final Future. The Destiny of Civilization and the Deep Future of the Cosmos. The next 1,000 years. The immediate future of human civilization is uncertain in a way that is unprecedented in the history of our species. Not because the forces arrayed against us are larger than those our ancestors faced. They faced extinction events, ice ages, volcanic winters, the collapse of Bronze Age civilization in ways still not fully explained. But because, for the first time, the primary threat to human civilization is not external. It is us. The decisions made by this generation and the next 2 or 3 about energy, about the climate, about the governance of powerful technologies, about the distribution of resources across a population that may reach 10 billion before it stabilizes, will determine whether Homo sapiens remains a single-planet species in a mortal race against its own capabilities, or becomes a multiplanetary, eventually a multistellar form of life that has secured its own long-term survival. The mathematics of existential risk are stark. A civilization that remains on a single planet is vulnerable to any sufficiently large impact event, volcanic supereruption, nearby gamma-ray burst, or self-inflicted catastrophe. The probability of any one of these events in any given century is small, but over geological time, over the millions and billions of years that the universe will continue to exist, even small probabilities become certainties. The only long-term security for a civilization is to expand beyond a single world. Not for the romance of exploration, though the romance is real. Not for the exploitation of resources, though the resources are real. But because the universe is dangerous, and a civilization that puts all of its existence in one place is a civilization that will eventually be destroyed by the universe's indifference. The possibility exists, genuinely, concretely, within the reach of technologies either already developed or plausibly developable within a few centuries, that Homo sapiens will colonize the solar system, then the nearest stars, then the galaxy. A civilization with access to the energy of a star, what physicist Nikolai Kardashev called a Type II civilization, and then the energy of an entire galaxy, a Type III civilization, would have capabilities that, to modern human eyes, are indistinguishable from the divine. The ability to reshape planets, to move stars, to construct artificial environments of planetary scale, to survive the natural death of individual stars by migrating to younger ones. Whether this is humanity's destiny, or whether it is a destiny reached by some other form of intelligence that either descends from us or supersedes us, is unknown. Artificial intelligence, systems that can think faster, more flexibly, and with greater accuracy than biological brains, may either be the greatest threat or the greatest tool in humanity's future, or both simultaneously. We are at the beginning of this story, not the end. The chapter is being written now, by this generation, by the decisions being made in laboratories and legislatures and boardrooms and bedrooms around a small blue world in the outer third of an ordinary spiral galaxy. The universe spent 13.8 billion years creating the conditions for a being that could understand it. What that being does with that understanding is the question that has no precedent. It is the newest question in the history of existence, and it is the most important question ever asked. 5 billion years hence, the death of the Sun. In approximately 5 billion years, the Sun will exhaust the hydrogen in its core. As it does, it will expand, slowly at first, then catastrophically into a red giant. Its outer layers will swell to engulf Mercury, Venus, and quite possibly Earth. The oceans of Earth will boil away billions of years before the final expansion. The atmosphere will be stripped away. The surface will be scoured by solar radiation and tidal forces to bare, lifeless rock. If any descendants of Earth's life survive, whether biological, technological, or some unimaginable combination, they will have long since departed for other worlds around other stars. The solar system, as it is configured today, has a remaining lifespan of about 5 billion years. 5 billion years is a very long time. It is more than the current age of the Earth. It is longer than it took for life to arise, evolve through every stage from bacterium to civilization, and reach the present moment. 5 billion years is time enough for anything. After the red giant phase, the Sun's outer layers will be shed as a planetary nebula, a beautiful glowing shell of gas illuminated by the hot, dense remnant of the solar core. That remnant, a white dwarf, roughly the size of Earth, but with roughly half the mass of the current Sun, will glow faintly for billions of years, cooling slowly into darkness. The matter that once fueled a star will disperse slowly back into space, eventually to be gathered by the next generation of stellar nurseries, the next generation of stars, the next generation of worlds. The atoms of your body will be part of this process. They have been through it before, forged in earlier stars, scattered in earlier supernovae. They will go through it again. The deep future, heat death, and the last stars. On timescales so vast they require scientific notation to express, the universe enters its terminal phases. The story does not end quickly. It does not end dramatically. It ends slowly. And the slowness is, in its own way, more profound and more frightening than any sudden catastrophe could be. In approximately 100 trillion years, 10 to the 14th years, the last stars will die. Star formation requires cold gas clouds, and the universe's supply of cold hydrogen gas is being consumed by star formation faster than it is replenished. The stellar epoch, the era of light, which includes the entirety of everything we have described in this documentary, is less than 1% complete by duration. The stars that burn now, including our Sun, are the young stars. We live in the early universe. In 10 to the 14th years, the last red dwarf stars, small, dim, cool, and extraordinarily long-lived, will exhaust their fuel and fade. The age of stars will be over. The universe will go dark, but it will not be dead. Not yet. Black holes will dominate the dark universe. The supermassive black holes at the centers of galaxies, the stellar mass black holes formed from dead stars, will persist and slowly merge and grow. They will orbit each other and occasionally collide, releasing gravitational waves, ripples in space-time that carry away energy and cause the black holes to spiral inward and merge. Over timescales of 10 to the 30 to 10 to the 40 years, the dead remnants of stars and planets will evaporate through quantum tunneling, their atoms literally tunneling through energy barriers that classical physics says are impenetrable, slowly reorganizing into lower energy configurations over inconceivably long timescales. Dead planets will become liquid, then crystalline, then quantum mechanically transform into iron, the most stable nucleus, over timescales of 10 to the 1500 years. And the black holes? In 1974, physicist Stephen Hawking showed that black holes are not truly black. Due to quantum effects near the event horizon, black holes slowly radiate energy, Hawking radiation, and gradually lose mass. Given enough time, even the most massive black hole will evaporate completely, releasing all of its mass as a faint, diffuse glow of thermal radiation. The time required for a supermassive black hole to evaporate completely is approximately 10 to the 100th years, a number so large that writing it out in full would require more zeros than there are atoms in the observable universe. But finite. The number is finite. Every black hole will eventually, given time enough, die. After the last black hole evaporates, the universe will contain nothing but a diffuse sea of photons, electrons, positrons, and neutrinos, expanding forever through an increasingly cold and dark space. The temperature will approach, but never quite reach, absolute zero. The density will approach, but never quite reach zero. This state, called the heat death or the big freeze, is the most likely ultimate destiny of the universe according to our best current understanding of cosmology. Not a dramatic end, not a big crunch, not a big rip, just an endless, cold, dark, diffuse equilibrium stretching on forever, in which nothing interesting ever happens again. The universe has a lifespan. It is not infinite. It was born, and it will end. And the end is not like the beginning, not a singularity, not a bang. It is a whisper, a fading, a long, slow, cold diminishment into a darkness more final than the darkness before creation, because the darkness before creation had potential, and the darkness at the end of time will not. Epilogue. When the last light dies, the final silence. Think about what has been described in this story. Think about it fully, without looking away. A universe born from nothing, or from something so strange that nothing is the best approximation available to human language. 13.8 billion years of expansion and cooling and evolution. The first atoms forming in the first minutes, the first stars igniting in the first hundreds of millions of years, cosmic furnaces forging the elements of chemistry and biology, galaxies assembling over billions of years from the mergers of smaller things. Around one ordinary star, on one of billions of rocky planets, in one of the outer arms of one spiral galaxy among hundreds of billions, chemistry becoming biology. A single cell becoming, over 3 billion years of evolutionary experiment, a biosphere. A biosphere producing, through the filter of 5 great extinction events, a species that could ask where it came from. A species that could stand on a small blue world and, for the first time in the history of existence, understand, even partially, even incompletely, the nature of the cosmos that produced it. And then the long unwinding. stars dying, galaxies darkening, black holes evaporating, the temperature dropping, the light fading, the long, cold night of eternity settling over a universe that once blazed with 100 billion galaxies worth of starfire. What is preserved from all of this? In the physical sense, nothing. The laws of thermodynamics are not sentimental. No record of humanity, no record of any civilization, no echo of any thought or feeling or love or discovery survives the heat death of the universe in any form that would be recognizable as a record. The photons that carry the information decay or redshift beyond any possible detection. The matter that made up every mind that has ever thought disperses into the equilibrium of the final state. In the cold arithmetic of entropy, existence leaves no permanent mark on the universe. It passes through and is gone, and the universe does not know that it was here. And yet, the fact that it happened, the fact that for a brief flicker in the incomprehensible duration of cosmic time, the universe was lit with the fire of stars and the fire of minds, is not nothing. It cannot be made nothing by the cold that follows it, any more than a beautiful piece of music is made meaningless by the silence after the last note. The music was real, the stars were real, the thoughts were real, the love was real. The universe had, for a finite and improbable and glorious span, the experience of knowing itself. The ancient myths were not wrong. They were telling this story in the only language available to them, the language of symbol and narrative and awe. The great cosmic ocean of none from which creation emerged and to which it will return. The Ragnarok after which a new world rises from the sea. The cycle of Brahma's cosmic days and nights, the Kalpa and the Pralaya, the day of creation and the night of dissolution, each lasting 4.32 billion years, repeating forever. The Book of Revelation's vision of the end of the world and the emergence of a new heaven and a new earth. These are not failures of scientific understanding. They are successes of human intuition. Every civilization that contemplated existence long enough and deeply enough arrived at the same insight, that existence is bounded, that it has a shape, that it began and will end, and that this is not a reason for despair, but a reason for attention. We are the ones who know. Among all the configurations of matter that the universe has produced in 13.8 billion years, we are, as far as we currently know, the only ones capable of understanding what the universe is and what it has done. We are the universe's mechanism for self-knowledge. We are the place in the cosmos where the cosmos becomes aware of itself. This is not a comfortable position. It is a position of profound responsibility and profound privilege. To know the story of existence is to be part of the story of existence in a way that no other known phenomenon is. Look at the night sky. It takes 8 minutes for light from the sun to reach your eyes. The nearest star beyond the sun, Proxima Centauri, is 4 light years away. Its light takes 4 years to reach you. The Andromeda Galaxy, the nearest major galaxy to the Milky Way, is 2.5 million light-years distant. The light you see from it tonight left before Homo sapiens existed. And the faint, scattered glow of the most distant galaxies, visible to the largest telescopes, left those galaxies when the universe was less than 1 billion years old, 13 billion years ago, when the Earth itself had not yet formed. When you look at the night sky, you are not looking at the present, you are looking at the past, at light that has been traveling for years, decades, centuries, millennia, millions of years, billions of years. The sky is a time machine. Every photon that enters your eye is a message from the deep past, from stars and galaxies that may no longer exist in the forms you see, from eras of the universe so different from our own that no life existed to look at them. You are the first living thing in that part of the sky's history to receive that light. You are the completion of a journey that began before the Earth existed. The universe has been traveling toward you, in a very literal sense, for billions of years. Every moment you spend looking at the stars is a moment of genuine cosmic significance, not metaphorical significance, not poetic significance, literal, physical, measurable significance. You are the universe observing itself. You are the endpoint of a 13 billion year causal chain. You are what happens when the laws of physics are given enough time and enough matter and enough energy and enough patience. You happen. You, with your fears and your loves and your questions and your brief, flaring existence on this small, warm world, are what the universe does when it tries its hardest. The last star will die in 100 trillion years. The last black hole will evaporate in 10 to the 100 years. And after that, the cold, the dark, the diffuse, eternal equilibrium that is the universe's final rest. The ancient mythologies were right to be afraid of this, even if they could not articulate what they feared. The Egyptians feared the darkness beyond the reach of Ra's light. The Norse feared the winter that would last forever. The Zoroastrians feared the final victory of Ahriman, the force of darkness and chaos. They were all describing the same thing, the thing at the end of all things, the cold dark waiting at the terminus of time. But they were also right about something else, something harder to articulate, something that does not fit neatly into the language of thermodynamics and entropy, something that every great tradition of human wisdom has intuited, from the oldest cave paintings to the newest physics, that the fact of existence, the sheer improbable fact of there being something rather than nothing, of matter organizing itself into life and consciousness and love and wonder, that this fact is not diminished by the cold that follows it, that the end does not negate the middle, that the universe's long journey from fire to ice, from singularity to equilibrium, was worth taking, that somewhere in the span of it, something happened that has never happened before and will not happen again. Consciousness happened. The universe thought, and in thinking, knew itself, and in knowing itself became something more than a collection of particles following mathematical laws in the darkness. It became a story, the greatest story that has ever been told, because it is not a story told by anyone to anyone. It is the story that the universe tells by existing, a story that required 13.8 billion years to reach its most recent chapter, a story that is still being written by every mind that contemplates it, including yours, including now. The first star burned. The last star will die. Between those two events, in the unimaginable interval between the first light and the final dark, something became aware. Something looked up. Something asked. Something, briefly, understood. That is everything. That is, perhaps, enough. The universe was not made for us. The cosmos did not arrange itself with human significance in mind. There is no evidence of a divine plan that placed us at the center of creation. We are peripheral, cosmically, spatially, temporally peripheral, small creatures on a small world in an ordinary corner of an ordinary galaxy, late in the first 1% of the universe's likely total lifespan. We are, by the cold measures of cosmic scale, insignificant, and yet, the universe contains no other known thing that knows this about itself. The universe contains no other known thing that found the stars beautiful, no other known thing that wept at the thought of the dying of the last light, no other known thing that built telescopes to see further than its eyes could reach, that built mathematics to understand what its experience could not contain, that built stories to give shape to the terror and the wonder of being alive in a cosmos so vast and so indifferent and so breathtakingly, inescapably, undeniably real.
You are that thing. Right now, reading these words, thinking these thoughts, feeling whatever you are feeling, you are the universe, doing something it has never done before and may never do again. You are the cosmos, experiencing its own history. You are the Big Bang, grown slow and cold and conscious, looking back at where it came from. Look up at the stars and know what they are, what they truly are, not the gods of antiquity, not the distant decorations of the night sky, but the cosmic forges that made you, the nuclear furnaces that built your carbon and your oxygen and your calcium and your iron from the hydrogen of the Big Bang, the ancestors in the most literal and the most profound sense of everything you are. Look up and understand that the light traveling from those stars has been traveling for years, decades, centuries to reach your eyes, that you are the destination of that light's long journey, that the universe, in the form of photons launched from burning nuclear fires, has been reaching toward you. And understand, finally, why every civilization that ever looked at those same stars, built temples to them, wrote hymns to them, carved their names into stone, mapped their movements with obsessive precision across thousands of years, because they felt, imprecisely, mythologically, but genuinely and accurately, that the stars were important, that the cosmos had a story, that being human meant being part of that story, that the most important thing a conscious being could do was to understand, to the greatest extent possible, the nature of the universe in which it found itself.
They were right. We are still doing it. We will continue doing it for as long as we exist. And when we are gone, whenever that is, however it happens, the universe will continue its journey toward the cold, dark end. The stars will continue to burn. Time will continue to pass. The laws of physics will continue to operate. The cosmic microwave background will continue its ancient journey through the expanding dark, carrying within it the memory of the first 380,000 years, growing ever fainter, ever colder, ever more diffuse, reaching no one, heard by nothing, a message sent to an empty universe. Unless something else arises, unless somewhere in the hundreds of billions of galaxies that the observable universe contains, in the trillions of star systems, on the billions of rocky worlds in habitable zones, unless other minds have already arisen or will arise that will continue the project we have begun, the project of understanding, the project of wonder, the project of standing on a small world under a vast sky and asking the question that only consciousness can ask. What is this? What are we? Why? We do not know if we are alone. We do not know if the universe's experiment in self-awareness will survive us. We do not know if there will be minds, anywhere, to watch the last stars die. But we know that we are here now. We know that for this moment, this cosmically brief, improbably precious moment, the universe is alive with light and thought and question. We know that the story of existence has reached, in us, a moment of self-awareness. And we know that what we do with that awareness, in this century, in this millennium, in whatever time we have, matters in a way that nothing else in the known universe has ever mattered. Because we are the only ones who know it matters.
And after the last star surrendered its fire to the dark, after the last black hole whispered its final photon into the void, after the long cold silence settled over all that had been,
The universe remembered nothing. But for one impossible interval, measured in the lifespan of stars, it had known itself. And that brief, burning, terrifying, beautiful knowing was everything that existence had ever been for. The end of all things.